My name's Hannah Jane, and this is Jake, and this is our Arduino Quadruped robot project. Okay, so our outline today is problem and solution, our constraints on what we could build, our alternative concepts, our engineering process on our final design, and our final design.
All right, so the basis of the project was that we needed a self-manufactured robot with 4 legs that needed to have a very specific walking motion. It couldn't shuffle. It needed to use servo motors and Arduino Uno, and we opted for 3D printing, as did most of the class, and that's the simple premise of it.
Alright, so our constraints were that there had to be 4 legs. He didn't specify how many servos we had to use, but he did say that we had to have servos. He said we had an Arduino. It had to be walking, so it couldn't shuffle or just kind of scoot across the table. It had to actually walk with the 4 legs. And it had to be self-manufactured, so we had to come up with the parts that we wanted to use ourselves. It couldn't just be some random part we found online. We could model it after other parts that we had seen before, but it had to be parts that we physically made, like an inventor, or we 3D printed them or laser cutted them or whatever we chose to do. Okay, so our alternative concepts was that we would have single servo legs, so that we would have one leg that would have 1 servo each, so we'd have a total of 4 servos, and we decided that that was probably not the best because it would have a very, very limited range of motion, and it would be kind of hard to balance as well. And our other solution would be to have double servo legs, which would mean that we would have 8 servos total and 2 per leg, which we decided that although it would give us more range of motion, we decided that 3 servos per leg, or a triple servo leg, would give us the most range of motion because it would have a hip joint, a knee joint, and an ankle joint, so it would be able to walk more easily than with a double or single servo.
And another large problem with the single or double was that, like we previously said in the constraints slide, it needs to be a very certain walking motion. It can't shuffle at all, so each leg needs to lift off the ground and move forward and move itself forward. Alright, so like we already said, the constraints were pretty cut and dry. It was 4 legs, it needed to have a walking motion, and it needs to be self-manufactured. So our original concepts, well, you can go over our drawings.
Yeah, okay, I'll go over the drawings. So our original concepts were, we considered many options. We had 4 or 5 options, I think. But one of the ones we considered was, it had, one of the ones we considered had double servos, so instead of 3 it had 2, and we opted to not to go for that one, mostly because we wanted more control and to have the proper walking motion we needed. We also looked at one that had legs that were 2 in the front and 2 in the back, but on the parallel with the sides of the rectangular body. But we did ours where they were more diagonal to the corners, because we figured that would give us more control over where the legs would step. And what else did we talk about?
Alright, so for our prototype, we decided to go, like we said, a 3 motor per leg setup, and we needed to manufacture 3 parts for the legs, the body part, and then basically any other brackets that we would need. And we went for 3D printing because we could just simply design it in AutoCAD and then print them pretty easily.
Mm-hmm.
And we definitely built our ideas off of other 3D printed robots online and other commercially manufactured robots that were sold in kits.
Mm-hmm.
And then I needed to learn how to actually code so that I could code the servo motors, and that took at least a week or 2. We had an entire IDE sketch of the entire movement pattern of the robot, and it basically needed to move one leg at a time and then kind of propel itself forward. And then for improvements, we needed to fix any spots that we found were either not holding the weight up or were just not moving properly in the way of coding. And we definitely needed to change the code quite a bit for this project. And we had several reprints. You can talk about the printing.
So the 3D printing, we already had a lot of trouble with not being able to get a printer in the beginning, because even though we have a lot of printers in the printing room, only a few of them were working, and so we did have some technical difficulties with fixing the printer if it was broken or waiting for one to open up. But when we did get them printed, some of the prints would mess up or malfunction because sometimes the 3D prints just don't print right, so we had to spend some time reprinting those. And sometimes we had sizing issues, and our parts that we had made didn't quite fit what we needed, and so we had to either make a new part to fit what we needed, or we had to change it slightly or size it up or size it down so it would fit in the spot that we needed it to fit, so that we could so that our legs would walk the way that we needed them to.
And then other improvements that we had to make after building the final robot were there was one CAD drawing that had the wrong measurements for how deep the servo would go. So I had to kind of manually adjust that. I had to kind of cut into the body, but it ended up fitting, and we got those figured out. And then the wiring diagram that I initially made was slightly incorrect, and it kind of caused problems for wiring and coding for about a week or a week and a half, but we eventually also got that ironed out, and now our wiring is good. We have the proper size breadboard, and our robot is now standing, and it's getting towards walking.
It's not quite walking yet, but at least it can stand, and it kind of shuffly moves-ish, kind of, yeah.
So yeah, our final solution was the kind of progressed 3D printed body and leg pieces with 12 total servo motors, lots of wiring, an Arduino Uno, and then we had a 4 AA's in a battery pack underneath the body. And that was another problem. I had to kind of change how the legs were going to be attached, because the weight, we didn't really account for the weight of the battery pack, which was probably
Pretty
about
heavy.
half of the weight of the entire robot. So I had to adjust that.
Alright, so our final design was called a spider. So basically we just had our legs diagonal to the corners of the body. We had 12 servo motors total, so we had 3 in each leg, and we had flexing legs, so we had 3 individual parts per leg that would attach to the servos, so that we could have mobility, and they would flex back and forth whenever they would walk forward individually.
Alright, so that's pretty much our entire process of going through from week 1 to now week 11, I believe.
I don't know how many weeks.
And yeah, that's really good. Alright, today we're doing our drop test for the Arduino Quadruped robot, and this is the robot, and we need to drop it off of this table height. Alright.
Okay, ready?
Okay.
We lost one. The rest of it's fine.
Alright, so these are our sketches for the Arduino Quadruped robot.